Hey everybody, this is Chris from Rift Tech Labs, and I'm back after a little while. Yep, sorry about that. Had some stuff come up. Couldn't be helped, but I'm back. Now what I want to do today is look at a pair of vintage capacitor checker devices. What we got here is this guy. This is a Century model 201. I think that's down here. Where is it? I saw it earlier. There it is right there. Model 201. I can't find any information on this thing. I do know that quite a while ago I opened this up and I recapped it and I played with it. I'll open it back up, check it out again, make sure nothing looks off. I think the tube worked. I don't remember. We'll stick some leads in here. I think these are the same as my Simpson 260. I think these are the same kind. Let's find out. Oh yeah, they're exactly the same kind of leads. So we'll just take those out of there right now. The other one is this guy, the Sprague Kwik Test KT1. Now this one I bought off eBay several years ago, and I have not even cracked this one open that I remember. This one's probably going to need capacitors replaced, tubes checked. If I can even check them, this thing uses some tubes I don't recognize the numbers for. I'll open it up and have a look. I've got the manual for this guy loaded up on the computer, so we can kind of look at that when I get to it. I'm going to check out this guy first, and then we'll take a look at this, open it up, look at it. We may have a slight delay in the video if I need more parts for it. Tubes are bad, whatever. But let's get started with the Century here and see what we can do, right? Get this guy out of the way. Now, if I remember right, you gotta be careful with this too, because this has some serious sharp edges on this front plate here. Almost cut myself taking it off the shelf. The cord, yeah, it's a little old and brittle, but if I remember right, it worked. It's probably not a great idea. I probably should replace it, but it didn't have any cracks in it. It you know, seemed fine. Like I really use it, right? That's the other thing, is this kind of equipment is basically useless now because we have animals like this, right? Now I've got a I want to see either a 0.2 or a 0.02 capacitor loaded in there, right? Now, you just stick that thing in there and you just go turn it on. Get a little Transformers logo. I don't know why it's got a little Transformers logo on it. Testing. I just checked this before I did this and it worked just fine. So I don't know what's going on. It's not, you know, I bought this off Amazon for like 10 bucks a while back. I don't remember what I paid for it, but it wasn't much. It does good for basic stuff, you know, checking capacitors, checking diodes, ICs, and there was a bunch of them you can stick in there and look at it. There it goes, now it's working. Really? Okay. Now see, I know this was working because I looked at it before I started recording just to make sure, and it gave me the right value. So I don't know what's going on with this. Try it again. Alright, switch banks in the thing here. Switch it off. Turn it on. Make some Decepticon sounds. Yeah, there we go. This is, yeah. So it's a 0.02 microfarad capacitor. It says, you know, 19.8 nanofarads, same thing. Well, you know, it tells you your voltage loss, which is your leakage, basically, I think. Correct me if I'm wrong down below. Yeah, that, I mean, this little handheld job it tells you exactly what it is. You don't have to mess around with stuff like this. What's the point of this? It's just, you know, somebody's got to keep this stuff alive, right? That's what we do here. Now, all right, let me find my flathead because I didn't come prepared. Turn these bad boys back out. I don't remember what the I-tube in this is. Like I said, I took this apart and replaced stuff in it several years ago, and I really don't remember it. I did it just to do it, kind of soldering practice type of thing. I don't remember. I think I bought this at a ham fest for like $5 or something stupid like that, right? It's in a pile of junk. I'm like, hey, what do you want it for? $5, you know. So now it's probably got off. No, it's probably, it's on there. Okay, so that's right. Okay. This is, yeah. So yeah, there's one electrolytic capacitor in here that I've already changed out, 40 microfarad. That's interesting, that's 160 volt. I don't know why. I didn't use a bigger one. Maybe I didn't need to. I don't remember what came out of it. I can't find manuals for this anywhere. The tube is a Sylvania. Let's see if I can get that out of there. There it is. Get some light on that. It's a Sylvania. There it is, 6U5. There we go. Focus. 6U5. Like I said, I'm pretty sure I tested this and it tested okay, and I remember it being in there and lighting up. We'll see what it does now. There we go. I did not replace the mica molds because they're pretty reliable, as that's my understanding. I didn't replace the resistors. I want to say I did actually check them, and they were okay. Yeah, I mean, that's the extent of this. Is this little guy here? You know, it seemed to work. Yeah, I was thinking there was more capacitors in there than this, but apparently not. So, and the transformer in there, it doesn't look to be in the greatest of shape. But I guess we'll find out. If it catches on fire, we'll know one way or the other, right? So let's button this back up. And I did some reading. There's a couple of threads on the Antique Radio forums about this, and nobody else can find any information about it. Actually, I do have an old ad from a magazine from World Radio History. It's a great site, by the way. You should go check it out. There's all kinds of good antique radio stuff in there. And it's just advertisement that lists it as being for sale. It doesn't have a price tag on it either. I don't think it was a kit because it, you know, is marketed by this Century company, Mineola, New York. Honestly, don't know where that is. Sorry. Let's see if I can prop this guy up so we can see what we'll do. We'll plug it in. We'll turn the voltage down, turn it on, because I think it just boop comes on the second you do that. Now I've got it on. Supposedly you can check resistors value. You know, like I said, if I understand how this works, you connect your component in question, whether it's capacitor or resistor. I might check it with the resistor just to see what it does. And then the tube here will, hopefully you'll see what I'm talking about. It'll like open and close depending on how close you are. It won't actually tell you the value. You have to kind of dial it in, right? Okay, let's turn it on. Okay, it does have a power switch right there. I knew that, right? Yeah, here's the entry for radiomuseum.org. There's really not much information here, just this one picture, right? Oh, 2 pictures, 3 pictures. Yeah, there's nothing else listed here for it. It says 1955 on it. But here, yeah, that makes sense though. October 1955. Century Analyzer. Century Electronics Company, blah, blah, blah. 201, condenser, resistor analyzer. Test condensers and resistors for quality and value. So it actually will check value, and if you've got leak, I don't know how that works on a resistor. That's kind of the entire point of it. If it's got but leakage, basically, you know, LCR, it's got internal resistance. That's your ESR on your capacitors, right? So it kind of, if it's got a high resistance, you'll see that on here. Unknown capacity values are registered on the dial. So if you don't know what it is, you can hook it up there and dial it until the tube does its business. And then you can go, oh, that's, you know, more or less what it is. I mean, to 150 microfarad. Okay, so I could, and I think I'll just do that. Just stick one in there, right? So yeah, I've got my 0.1 microfarad capacitor in here. Got it turned on. It's warming up. That's all that's got to warm up is just the tube here, right? And you can see there's kind of a gap right there, right? So let's see here, 0.1 MF, which is only right here. So, but if I turn the dial, you can see it open up and close again. So I passed it. There should be, yeah, if I remember right, it opens up at the required value. Let me, this knob, I need to check. I thought there was a pointer on it. Oh, there is a very faint, yeah, there's a very faint line on there. You cannot see it. Oh, there, you can kind of see it right there. I should get a paint marker out and spruce that up. Let's try it with a smaller capacitor, since that's what these other ones are. Let's turn it off and turn it back on again. I'm looking at my screen here. If you think, oh, where am I looking at? Yeah, I can see it better up there because of the angle, whatever. So 0.02, well, it's still only right there, but okay, I gotta mark this dial better. Kind of just give that a little dot. Or not. Okay, there we go. There. There's our indicator, right? So we got 0.02 is right here. Turn it, it opens up, and then it closes again, right? Open is at maximum open. Yeah, it's kind of a little flaky. I don't know if that's because of the variable resistor or whatever that is on that. It very well could be, but yeah, I mean, that's all there is to it. Now, you're gonna go for quality, right? Which I'm assuming is wide open. Now, since it's a brand new capacitor, it's not shorted, right? I should be able to turn this up until it gets all the way and nothing happens. Oh, that's neat. Okay. So, that doesn't do anything. Cool. Maybe that's good, I guess. If there's nothing to see, then I guess that's probably good. Let me get a resistor out. Let's see, what's the scale look like on this? 100K, 1 mega ohm. Let's just try 1 mega ohm. Hopefully, 1/4 watt is not too small for it and it doesn't burn up or something. I don't know. That's a good question, isn't it? So we've got it on resistor value. Now, turn it back on and see if this resistor burns up or not. Well, that's interesting. Oh, there it goes. Okay. So it's 1 mega ohm, right? We should be able to turn this to, yeah, there we go. Here's 1 mega ohm on the scale, and you can see it open up and then close again once you pass it. So, yeah, I mean, for 1955, I mean, that's pretty slick, right? And that's basically all there is to it. But you can do that with the regular digital multimeter. You can do that with that silly little Decepticon tester I used. Is that even warm? No, I didn't even get warm. So, okay, that's cool. Plug it, and we'll put this away, and we'll open up this Sprague and see what it looks like inside. Like I said, I have not opened this up at all. Actually, before we do that, let's look at the manual and the specs and stuff on this. Here we go. Right? Sprague model KT1. Yeah, it was whatever I downloaded these from in the past. Oh, I guess that was from Radio Museum. Here's the thing right here. But it was per page. Oh, it's even got my name on it. Now that's pretty slick. Huh. Yeah, don't get me started on radiomuseum.org. Sorry, Radio Museum guy, but yeah. Okay, purpose and usefulness. Let's see if maybe I can zoom in on that some more. Sprague model KT1, blah, 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 will quickly and easily indicate open, shorted, and intermittent capacitors without removing them from their circuit. Don't ask me how that works. Any capacitor within the range of, I mean, that's a pretty decent range, right? 2,000 microfarads. Wow. Even though parallel with a resistance as low as 60 ohms. DC operations and under no circumstances should be plugged into a DC outlet. Now, I'm not up on vintage electrical systems, but I don't know how you plug that into a DC outlet. I mean, I guess it's possible. I guess maybe if you got like an old farmhouse or something that ran on DC power. I don't know. Tube complement. This is where I'm a little like, if these are bad. Two 1626 and one 1629s. I don't know that my Jackson tube checker has those numbers on the dial. I'll get it out when we get there, I guess. Yeah, and here's the big problem. Molded Sprague Telecat paper capacitors are used whenever practical. Yeah. The fixed capacitors in the... Oh, so maybe we don't need to change all these. Sprague ceramides. So they're... Oh, okay. So maybe I don't need to change those. I got out capacitor values from my stash just from the parts list, which we'll see here in a second, just to... But yeah, I didn't see that part, so that's interesting. Next, Here's your short test operating procedure. I mean, you've got full-on diagrams here, so we'll come back to that, assuming I get this thing working and the tubes check out. Full schematic. Now this part here is interesting to me, right? Okay, zoom in down here. Blah, 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 for long time stability. Okay. Readjustment. So I guess basically you're just zeroing it out. I don't know. But this part here, do not alter the length of the test lead under any conditions, since it's part of the quarter wave line as explained in 3.1. Okay, let me go back to 3.1 here and have a look at that. Basic circuit which operates as follows. An impedance Z1 constitute a quarter wave transmission line operating at a frequency of about 20, is that megacycles or millicycles? It's got to be megacycles, because millicycles would be dumb, right? Okay, useful property of a quarter wave line utilized in this test, namely, impedance connected to the output end of the line is reflected to the sending end as a reciprocal. Okay, if I just one-shot this almost is acting like a kind of SWR meter. Is if it sees anything coming, I don't know. Operation if the test clips are open or connected to an open capacitor, the sending end coupling coil inductor sees a short circuit, 0 voltage. Okay, which causes the eye to remain open. Any capacitance connected to the clip results in a voltage across the L2, which is rectified by the 1N51. Now wait a second, hold on. 1N51. Oh, wait. The 1N50, hold on. Just, no, this page here. 1N51, is that like a, yeah, it's got a, okay. I was going to say that sounds like a diode, and yeah, it's a, oh boy, look at that old tube. Yeah, we might have some issues with these tubes. That's a good question. Well, I guess we'll find out, huh? Where was I? But as I was saying, the length of the test lead under any do not alter the length of the test lead. And this is where I have a problem, right? Because our device here, this test lead is in really crappy shape. Sorry for the bouncing. I'm trying to zoom out. I mean, yeah, it's just wrapped up with duct tape, with electrical tape. The rubber wiring on this part of it is shot. Let's just call it what it is. I might be able to sleeve that or replace that. I'll have to like take this tape off and see what I'm looking at. That could be a big problem. It's all cracked up, exposed wiring everywhere. Looks like maybe somebody's tried to fix that with whatever this is. I don't know. And all the tape on there. Yeah, and this is, it feels okay. It's got some marks on it where it's been tagged with a soldering iron before. Hopefully that didn't go through the shield, if it's even shielded. But yeah, this part here concerns me. We'll cross that bridge when we come to it, right? Return your KT1 registration within 5 days. Okay. Okay, anyway, the trimmer is correctly just, yeah, so that's, you're basically zeroing it out. Here's the parts. Oh, okay, yeah, those are all, there's just a couple of paper capacitors. I just saw where it said capacitor and just got them out, but yeah, the ceramics should be fine. We should probably check them in the Sentry maybe. Yeah, here we go. Molded paper, fixed dry electrolytic, double 10. I have those sitting here, and they're 450 volts. What I'm going to replace them with. So you've only got 2 paper capacitors here, and the rest of them are these trimmer caps, which are silver ceramic, mica. Ooh, and yeah, these 1, 2, 3, 4 ceramics. Okay, and then you've got these 2 tubes, 1626 and 1629. Yeah, we'll see what that looks like when we get into it. And then the silicon rectifier, which could be a trap shoot, and we might end up skunking ourselves out of the lab. And the video will be over because, yeah, I'm not really sure how to deal with that. I'm just kind of winging it. And the last page is kind of just what it looks like, which is actually good because it points out what the, what each component is, where it is, which is really important, right? So, I mean, that's where we are with this. Let's see about cracking this open. Oh, and that was another thing. It still has the original price tag on it. I mean, even if I don't get it working, I'm just going to leave this like this patina. I mean, with the original tag on it, original stickers on the back here that are pretty rough. I mean, it's rusty, but I'm not going to mess with it. I'm going to leave it like it is no matter what, assuming it works at all. So now we got to figure, okay, we got screws on the side. Of course, they're flatheads. Hopefully they just crack free. Guess we'll find out. Oh, did it move? Oh, hey, we're in. Almost. Turn. Come on. Yeah, we have rotational motion. All right. Okay, we are in business. All right, we're in business. Okay, so that happened. Now, where does this come apart from? Oh, we got 2 screws on the back here, too. I guess maybe I should go back to the manual and see if it says how to actually take it apart. Now we gotta get it apart. Yeah. Yeah, sure. Easier said than done. Oh, hold on. Haha. I don't know what's gonna fall out of this. Like I said, I've never had this open, obviously. Cat out in the hallway screaming like an idiot. Come on, you can do it. You can do it. Well, I got 3 corners to move. Why can't I get this? There we go. All right. Is there anything connected to that back? No, it's just the wires. Okay. Okay, those are old tubes. Big old globe type. So my tube tester will probably have provisions for that. Probably. Yeah, this one might be a challenge. I don't know. Okay. So, here we are in. Big old transformer. Here's our caps on the bottom that we got to deal with. Let's test out my fancy new electric duster. I'm not sure this is going to work. I got this thing off Amazon. I figure, hey, you know, canned air is just stupid expensive now. This costs as much as like a case of canned air. We'll give it a shot, right? Cover your ears, kids. Yeah, it's not as good as a blast of canned air. That, you know, hit canned air, just boom, you know, is on. That thing, yeah, I don't know. Time will tell, I guess. But yeah, those are all the ceramics. Those should be okay, I think. Although that one, actually, they all look like maybe they're burned up. Ooh, you can see what I'm looking at here. Zoom in. Give me some light. Yeah, I don't like the discoloration on these capacitors right here. I do not like that at all. That one's got it. That one's got it. Even this guy's got it. This guy. Yeah, I don't know. It's possible this thing's shorted and like, oh, yeah, I don't know. The Sprague Coulomb. Is that supposed to be like a science pun there? Like the Coulomb, like it's the unit of charge is the Coulomb, you know, C-O-U-L-O-U-M-B. Coulomb. I think that's how you spell it. Yeah. Coulomb. Or was that like Kool-Aid? I don't know. But that's ridiculous. I've never seen that before. Okay. I mean, none of these resistors look burned up, so maybe this thing's just seen some use and that's just heat discoloration. I don't know. That's wild. What else we got here? There's your trimmers, which are accessible from the outside. Where's the... And then you've got your electrolytics in the can there, which we'll do from the bottom because there's room. If I can... Yeah, that's where they go. It's right here. 1, 2, 3 terminals. I'll have to figure out which ones. Oh, that's easy. Negative terminals grounded, so that'll be straightforward. We'll just cut that and reconnect Our electrolytic's on the bottom. Ooh, that's a coil. Okay, that's what it was talking about. Is that a coil or is that a cap? No, that's just a coil. Okay, I was like, God, that's like a capacitor wrapped up in wire. But no, that's one of the, that must be one of the inductors. Okay. So this does not have... Yeah, it does. Where's that at? The silicon... the diode. Which one is that going to be? This guy here, maybe? Well, let's find out. So we've got... Okay, zoom in, baby. Let's go. We're looking at this. Ion... It's 1N51. So we're looking at this like this. So yeah, that's what that is. So yeah, what you've got here is... Here's our silicon, our diode. And here's just an inductor, which, okay. That tracks. All right. Wiring seems to be good. It's all braided, so it's not like disintegrating. Could be disintegrating inside, but we'll just have to take our chances, I guess. So yeah, these paper caps here, here, and here have to go. This one... Oh, that's a 30... Oh, that's a resistor. That's not a capacitor. Duh. 30 ohm, 10 watt. Yeah, that's a big power resistor. Okay. Huh. Today I learned. Here's another one of our ceramics. All these ceramics with the heat damage. That one's like completely discolored, which is... I don't know if that's what it's supposed to look like or what. I can't tell if this one's got any discoloration or not. But yeah, the tubes. Let's see about popping out this eye tube. Pretty dusty. I don't really want to clean it off because I don't want to remove any markings on it. Yeah, those are pretty dusty, but they don't appear to be, gassed out, so. But we'll get this out of the way somewhere. And let's get out Mr. Jackson. Hold on. Good old Mr. Jackson. Whoops, I got him upside down. Good old Mr. Jackson. Mr. Jackson here. Zoom out. Yeah. Mr. Jackson is in need of a cosmetic makeover in the worst way possible. This goes off. But it basically works. Okay, so let's see if I can get... Yeah, come on. This might be easier said than done. If we can get the dial. I don't know if I'll be able to zoom in on that with the camera setup I got right now. Here we go. 1629, visual test. Okay, so Mr. Jackson, let's plug you in. So apparently that'll just, if we see it light up, that means we're in business with the iTube. So that's, I'm assuming that's what that means. Right? Before I turn on the power, let's dial this in. And you guys are looking at those buttons going, what are you talking about? Okay, so let's dial in dial in the tester here. You have to just trust me here. So we got filament, which is here, 12.6. Okay. Like so. Plate is 20. So we have a visual test and we have like the current test. Okay, 20. Oh, Mr. Jackson's a little dusty. Let's release all of those. Circuit D, 1, 2, 3. Circuit E, A, 4, 5. Now, yep, right there. Okay, so there's that. Let's make sure we don't have any other set that we don't want to. There we have shorts test. I think that's right. I think. If it's not, I'm going to blow this tube up, and I'm probably going to regret it because I have not looked up what these cost to replace. So let's turn on the power. We have voltage where it belongs. Current, yeah, current on that is a little, it doesn't want to grab the thing correctly, but that's neither here nor there. All right, so, oh boy, okay. You can see this down here, the top row for the 1629. I'm just going to double check. That does say 1629, okay. Because I've done that before, blowing tubes up, because I read it wrong and screwed up. All right, turn this on and see if that warms up. Okay, we have, that's what the line control is. It's just, yeah, center that up. Okay, I can't see any, but that doesn't mean anything. Oh, there's a little faint orange dot down inside of there. Ooh, yeah. Okay, like really small, but it is there. So that's interesting. Okay, and then W and X is what it's got here for your plate test. You got plate and test. 20 is for your plate current, I think. I don't remember. WX. So you hit WX at the same time. That's not good. Might need to warm up a little bit. Let's just let it sit there. I have seen that where it takes a minute to come around. Yeah, that's not good. That's not good. Okay. Well, okay, so let's filament 12.6 plate 0. Then we have D 1, 2, 3, so I didn't need to clear that. And then E is C 4, 5, 6, right? And then to test that, it's just W. Okay, so this eye tube might be garbage. Oh, yeah, okay, yeah, I'm pretty sure that tube's trash. Well, all right, well, we'll test the other ones. I guess what we're gonna have to do is see about getting some replacements, see what those cost. If I'm not gonna spend a ton of money on these tubes if they don't cost like less than 10 bucks a piece. I'm not even gonna mess with it. It's just gonna sit on the shelf and look pretty. And this will be a real short video, and I'm not even gonna bother trying to recap it. So I'm just warning you right now. Yeah, that's not going anywhere. Okay. Okay, well, there's our 1629. Is it warm? No? Okay. Now, these two are the, what were these? 1626, which is in the line right above it. How nice. Okay. Also octals. 12, 6, and 22. Then we have 1, 2, 3, and A4, 6. Okay. Sometimes what'll happen is the tube will, your filaments will glow when it's just sitting here warming up. Sometimes, not always. It just depends. You can't see anything. I can't see anything. So let's see. To test your 1626, we hit W and Z. Whew. Let me make sure I have this correct. 1, 2, 3. A4, 6. 22, 12, 6, and WZ. Yeah, okay. That's cool. Yeah, it's not even increasing. It's just, blah. It's like, nope, sorry. I did not test for shorts at all. And what'll happen is if I got a short, that'll light up, right? I think I don't even need to press anything for that. It just does that, if I remember. And where'd the other one go? There it is. Same thing. Let's do the shorts test first. Ooh. Oh, yeah. Okay. That bad boy's got a short. That's neat. Okay. If I hit WZ, It says good. This one's actually got something going on, but it also says I got a short on K, whatever the heck that means. I don't remember. But it does say that that one's good. So that's interesting. So one of them tests good, but shows a short. Triode symbol from top to bottom. Anode grid cathode. And the heater. So yeah. So the emitter is shorted. The filament is fine. So that one's bad too. Alright. Well, let's get Mr. Jackson out of the way and let's see what we can find on the B of A and see what kind of trouble we're in. Like I said, I'm not gonna put a lot of money into this, so this might be a wild goose chase if I can find them cheap. And cheap is relative, right? Tubes aren't what they used to be. They're kind of, I think, fairly expensive now. I think I bought some tubes to fix some of these other radios, and I was a little shocked how high they've gotten in the last 10 years. Let's find out. Try that iTube first. 1629 thing. Yeah. That one's not terrible. 1629 vacuum tube new in box. It looks like a net. I'm just curious. What the heck is that? How can that be an iTube if it's in a... Huh? That must be a totally different animal. Yeah, must be. $17. Okay, plus shipping puts it just over 20. I don't know. For a piece of equipment that I'm never going to use, I don't think it's worth it. I just don't. I hate to say that. What about the other ones? What about the 1626s? Yeah, the same. Well, okay, there's one that's, yeah, like I said, this, I'm not going to sink this money into this. Somebody wants to front me the money for tubes, I'm all for it. What do we got here? Pair of RCA VT137 1626s. Does it say what brand these are? Those are RCAs. I thought that looked familiar. Okay. So, I mean, yeah, those are definitely RCAs. I don't think you can tell because it's printed black on brown. Well, I'm going to have to add these to my cart and think about it. I don't know. Because you're looking at 25 right there for the pair of 1626s, and then another almost 25. I'm not sinking $50 into this. Not for something that's just going to sit on the shelf. Yeah, that's too bad. I kind of wanted to see this in action. So yeah, that stinks. I was kind of hoping that would be easily and cheaply repairable. I was hoping the tubes would be good. I was really hoping they'd be good. So yeah, that's kind of a bummer. It's not worth $50, and then having it not work anyway, have that diode just blow up or something, and yeah, but that's kind of the game we play with this stuff. Is if it can be fixed easily and cheaply, then yeah, let's do it. But yeah, there's a point where you go, no, I'm not doing that, and I'm not doing that. Like I said, if somebody wants to put up for the tubes or send me a pair of working 1626s and a 1629, hit me up in the comments, I guess, and we'll see what we can do. And then I'll come back and recap that thing and see how it turns out. But man, I'm sorry, that stinks. So I guess thanks for watching. Sorry that it ended this way. If you like what you see, hit subscribe, hit like. Try to pump me up in the ranks here. And I guess we'll see you in the next one. I don't know what else to tell you there. So, you're awesome. Take it easy.